Now we are going to see methanogenesis and the carbon cycle in Arctic environment. The first one is climate change and the permafrost thawing. As temperature rise, permafrost is beginning to thaw, releases previously trapped organic matter. This organic matter becomes available to the methanogenic microbes, potentially increasing the methane emission. So the permafrost degradation leads to the more microbial activity. Thawing permafrost may lead to the release of large amount of methane that has been stored for thousands of years. This is a problematic one because the methane is a potential greenhouse gas contributing to further global warming. So that means direct release of methane also affects the carbon cycle in the Arctic environment. When we look at the methanogenic microbial activity, the methanogens in the Arctic have adapted to very low temperatures, but increased temperature from climate change can alter their metabolic rates and potentially lead to shifts in the microbial community. So this is what with respect to the temperature sensitivity of the microorganisms. The methanogenic activity is highly temperature dependent, so cold temperature can slow down microbial metabolism, whereas warming could increase activity and emissions in other cases. So the activity and growth is related to the temperature. When we look at the next one, which is the carbon cycle dynamics, the thawing permafrost can change the balance between carbon pools in the Arctic soil and sediments. This will lead to shift in types of organic matter available for the methanogenesis, affecting the overall carbon cycle. Similarly, the release of ancient carbon from the thawing permafrost result in the release of carbon that was previously stable and stored. When these are released, this will impact the global carbon budget and potentially accelerating the climate change. Similarly, when we look at the hydrology and wetland changes, the thawing permafrost can alter hydrological patterns, leading to change in wetland distribution and dynamics. So this affects the habitats where methanogens thrive and can influence methane emission. So how does the hydrology change? Basically, as the permafrost thaws, new wetlands and water bodies are formed, which will potentially create new environment for the methanogenic activity, but they also become potentially increasing the methane fluxes. So this is how the hydrology and wetland changes due to climate change affects the carbon cycle in Arctic environment. The next one is the ecosystem feedback loops. Warming and thawing can lead to changes in vegetation types and distributions. So this influences the type and amounts of organic matter available for the methanogens, and it affects the carbon cycling in the Arctic ecosystems. This is due to the vegetation changes, and when there is an increased methane emissions, this will contribute to global warming, which can further accelerate permafrost thawing. So there is a feedback mechanism that is operating here. And how do we know all these changes are happening? Because we can monitor the methane emissions and carbon cycle dynamics in the Arctic, but it is a challenging one because the Arctic is a remote region and it has harsh conditions. Limited data can hinder our understanding of the full impacts and the trends in these environments. Similarly, accurate modeling of methane emission and carbon cycling in the Arctic requires complex simulations that account for a wide range of variables. So these models are often uncertain due to the complexity of the process and the variability of environmental conditions. So this is a major challenge we are currently facing. And how this affects the ecosystems? Mainly the changes in the methane emission and carbon cycling can affect the Arctic ecosystem. Consequently, the livelihoods of the indigenous people and the local communities that live or rely on these environments for sustenance and cultural practices. So the methanogenesis affects indirectly the people who are living in the Arctic region. And assessing this broader impact of these ecosystem services such as carbon sequestration and climate regulation is a very complex phenomena that requires interdisciplinary approaches and long-term studies to understand what is actually happening in the Arctic region. So let us look at the various climate change mechanisms and the pathways. The first one is the feedback mechanism. One is permafrost thawing, which we had been seeing so far. The thawing of permafrost released trapped methane. The second one is the wetland expansion because of the permafrost thawing. So the warming temperature creates new wetlands, increasing methanogenesis. And what are the different pathways by which these reactions happen? One is they disrupt the carbon cycle. So the methane release adds to the atmospheric carbon pool. Second, the hydrological changes is basically the change in water distribution affect the anaerobic conditions by which the methanogenesis methanegenesis actually happens, and what are the climate mechanism by which all these things are happening. One is the positive feedback loop, that is increase in the methane emission lead to further warming causing more permafrost thaw. So this is the positive feedback that is happening. And when we look at the atmospheric chemistry, because we had seen in the previous module also regarding the pollutants are being transported, and also the atmosphere has greenhouse gases, basically the methane. So how these climate mechanisms affect the carbon release is basically the methane contributes to tropospheric ozone formation, and we will be looking at the mechanism by which how these reactions are happening in the subsequent modules. And how do we actually study? Even though we say like it is very difficult to study, we can still carry out various studies. One is the field study. So permafrost cores can be analyzed. So analyzing methane content in permafrost cores gives some rough idea about how much methane is actually present. The second one is measuring the methane emission from soil and water gives the gas flux measurements. So that through that also we will understand. These are the field studies which we can actually carry out in the Arctic region. The second one is through the remote sensing. So here satellites are generally used. The monitoring methane concentration and emissions, that is the very purpose we are going to do that. And how do we do that? Satellites are there. TROPOME, GOSAT are some of the satellites by which we can actually use the analysis of the methane concentrations and emissions in the Arctic region. And we can also carry out the climate modeling. So simulation of future methane emissions and climate impacts can be predicted through these models, and GCMs and that is general circulation models and Earth system models can be used for studying the climate change that is happening in the Arctic region.